A Rukia, ela também é Google Developer Expert, ela vai se apresentar um pouquinho. A Rukia, a apresentação da Rukia vai ser em inglês, tá? Também. Mais uma mulher representando aqui as mulheres na tecnologia. A Rukia, ela também é mais uma mulher internacional. As duas mulheres que tivemos aqui, a Vitória, do Peru, e a Rukia da Arábia Saudita. Então é um prazer imenso ter mulheres aqui representando o time de tecnologia, né? E mulheres aqui trabalhando em times internacionais, então para também promover e, de certa maneira, intensificar aqui as mulheres aqui no Brasil, né? Ser um time que inspire as mulheres a cada vez mais participar da tecnologia, tão importante. Então, vou mudar para o inglês, para dar boas-vindas para a Rukia, e espero que todos gostem. A Rukia vai falar um pouco mais sobre TensorFlow.js, deploy usando o JS, então, pessoal que tinha dúvidas sobre o TensorFlow.js, fiquem à vontade, e no final a gente pode entrar com algumas perguntas. Ok, Rukia, welcome again. Thank you very much to join us. It's a very pleasure to have you here.
Yeah, thank you very much. Hello, everyone. I am so glad to be one of the speakers at the TensorFlow Pocket Summit. Thank you all attendees from each country. I guess most of them from Brazil. I love the Brazil people, and I hope to visit Brazil as soon as possible.
Oh, very nice.
Okay, I wish to visit soon. So I am really excited about talking something I really love, something related to machine learning, TensorFlow, exactly TensorFlow.js. Today, I want to tell you about how TensorFlow.js make the deployment easier. I will focus how to convert Python model to JavaScript and deploy the model easily. So let us start. Before we start, I would like to introduce myself. My name is Rugia. I am Google Developer Expert at machine learning, as well as I am a Women Techmaker Ambassador. Currently, I am a member at the research and development part at pela, which focuses on the research of AI and data science. I spent most of my time with applying machine learning and trying to find the easiest way to deploy my model, as I have background on software engineering as well as development software. So that's a bit about me, my background, and what I do. Today's agenda, which is the exciting part. Here, what I will go. The first thing I want to give an overview about TensorFlow ecosystem. I want to explain the advantage of using machine learning in the browser, or why machine learning in the browser. Then I will give an overview about TensorFlow.js and how it is used through run existing models, or retrain existing models, or develop machine learning with JavaScript directly. After that coding part, I will write a model using JavaScript. It's very simple. Then, just for show, then I will import Python model, Keras. It is a Keras model. I will show a simple example to get how start. Then the last example about predicting home price. So far, so good? Oops. So, overview on TensorFlow ecosystem. TensorFlow provides a collection of workflows to develop and train models, no matter about the language. You can use Python, you can use JavaScript, you can use Swift, and there are many ways to easy deploy in the cloud, in prem, in the browser, in the devices. And today I will choose JavaScript or TensorFlow.js. Actually, I have a background in Python more than JavaScript. So I always convert my models, which build with Python after it's trained, using TensorFlow.js in order to create quick demo for my model, then deploy my model with zero cost on GitHub pages, just quick demo. So I always use Python, then convert to JavaScript, quick demo in GitHub page. As you see in the screen. Okay. JavaScript is very powerful language. If you go in the last Stack of Overflow surface or go to GitHub, you will notice that JavaScript repository have been most popular repository. One interesting article from a couple years ago is JavaScript is eating entire world. Why? The idea is that JavaScript language of many things. Language for powerful front end. I think you hear about Angular from Google, React, jQuery, and so on. JavaScript language for back end. Today, JavaScript runtime is popular tools to web browser surface. Maybe the reason Node.js, mobile apps also. Take a look at progressive web apps, BWA. It is a good example. API integration, JSON. What is JSON? JSON is JavaScript object notation, and it is widely used for integration. So, and so on, more example. Okay. Now, why machine learning in the browser? At this point, maybe you are thinking, are there other benefits you can get from using machine learning in the browser or using TensorFlow.js? The answer yes. So machine learning in the browser is really interesting. It is actually interactive. Here, the top reason why machine learning in the browser. The first is if you use the case has to do with privacy, or if you want to easy distribution, or if you want low latency, as well as if you want interactivity. Let us explain the first one, privacy. With running machine learning model in the browser, you get the opportunity to offer really strong notion of privacy. Most of the time, you find software companies their efforts to predict data. Are you agree? Okay. However, with TensorFlow.js, you can offer a different kind of privacy. If you have a company, for example, if you have a company, you can say something like, we don't see your data. It is never get to our service. As the opposite, if you say something like, we see your data, but we promise to keep it and keep it safe. What's the difference? Yeah, it is better. We don't see your data. It is never gets to our servers. On other side, if you are one of the end users, many cases the user data or is sensitive. So how about we move to the model and compute it totally in the browser, perform or computing prediction on the browser, so the data never gets to the server. That make the end user more comfortable. To be sure, let us do this experiment. This is a model converted model using JavaScript. After this session, go to this link. Once the page loaded, disconnect the internet connection. Enter here the value and click prediction. The prediction or click the button of predict. The prediction will appear. What's that mean? That means the model fetched on your browser and didn't send any request to the server to predict the house price. I hope you get the idea. Okay? So, the model fetched in your browser. Don't send any requests. And please do this experiment. So, the other interesting idea around machine learning is the browser. And the browser is related distribution. Anyone here who wants to get machine learning and trying to install TensorFlow or Python using pip or Aconda and so on? It is a bit difficult process for beginner. Do you agree? Sometimes error with installation or dependency issue. In TensorFlow.js, there is no install anything, no devices, no dependency issue. As well as it is simple, just go to the URL, open web page, and everything works. In addition, you can deploy the model using NPM. You can actually have all the benefit of model hosting, versioning, or distribution library through NPM. Or you can host easily on any statistic page host like GitHub pages with zero cost. It is just JavaScript. Latency. What I mean? Latency is the delay between user action and the web application response to that action. It is the delay between request and response. These days, models can be optimized and run really fast in both mobile and browser. In some cases, it is actually faster than model in the cloud or in the server. This is the benefit, low latency. In addition, you can, if you don't have fast internet, you can download the model and run locally and get the benefit of prediction. It is does not depend on internet connection. Okay. Last thing, or the finally of why machine learning in the browser, interactivity. The browser is designed to interactive design or experience. You can use or reach to the data that are available in the browser, like stream video, webcam, or record your voice using microphone or sensors, or upload files smoothly. JavaScript is powerful to reach to all resource in your device, in your browser, as well as interactive with user clicking or listening to the action, and so on. Okay, so how to use TensorFlow.js? There are 3 cases. Let us list them. First case, run existing model. Use official TensorFlow. There are already modeling ready to use. Just import them, or convert your model, Python model, Keras, for example, which always I did, and run in the browser using or using Node.js, but we will cover the browser. In this session, we will cover the browser. So the next case, or the second case, retrain existing model. Use TensorFlow or transfer learning to customize your model using your own data. So you can train your own data using retraining existing model by transfer learning. The third case, develop machine learning with JavaScript. I mean, you can build and train models directly in JavaScript. So far, so good. Before we start coding part, okay, let us start coding part. Okay. Let me show briefly how you can write your model using JavaScript. One interesting thing is the TensorFlow API is similar to Keras, which Keras is a framework for training neural network models. If you're familiar with Keras, that means, or you can easily deal or work on TensorFlow.js. Let us explain the code. First thing here, we load this tag, which load TensorFlow.js. After that, this is symbol script. We define model, sequential, TensorFlow here, define TensorFlow. This is the model, add layers, 1 unit, input 1, After that, compile like Keras, define the loss, mean square error, and optimize SGD. So after that, we create the data which we want to train. X data and Y. This is like features, and this like target or label. If we enter 1, x1, y will be 1. If we enter 2, y will be 3. X3, y will be 5, and so on. This is generated data. Data will be fit using fit method. Then will we predict like Keras exactly. This is input data for predict, and that is all. Very easy. You can see the demo here and the code. This is the code. Very easy. And the model, the demo. Okay. I put here alert. Just say click to view source, to view code, and click inspect console to view the output, because print in the console. Okay, so easy so far. What about import and convert Python model? It is another interesting thing. We can import model Keras or TensorFlow saved model. We will cover Keras, import Keras. Okay. There are many steps. I will go through this step. First step, install requirement. How install requirement? Just if you use Google Colab, put this mark and pip install TensorFlow.js. Next step, convert existing Keras model to TensorFlow.js layer format. How? First, save your model. After training your model, save your model with the path. For example, my model .eth5. This is for example. Then you can use bash. Use this command. You define the format, Keras, the path, then the output path. The output from using this command like this files. One of file called model JSON, and the second is binary file contain the weights. Let us go. By the way, sometime one file, binary file, sometime more than. For example, here it is 96 file contain the weight of the model. Here, because it is very simple, just one of one. Let us go through. This is model JSON. It is contain all topology of the model. Read the layer. Please read here the format, the layer, the Keras version, and here the weight, the file that contain the weights. which group 1 shared one of them, which contain the weight of the model. If we have more than one file, a binary file, so the result will be all the files. So what happened exactly? The model go to model JSON, the website or the page go and load model JSON, then model JSON connect with weights in binary files. Okay, there are another way to convert Keras model from Python to JavaScript using Python. We import TensorFlow.js as simple TFJS, define model method, the same we do in the Python, Keras, compile, layers, and fit. Last line, that's the new line, which convert the saved model. We pass the model and the output directory or the target directory. I hope it is so far so clear. Third step, load the model. Okay, now the model is ready for use. We want to load the model into JavaScript. So we put the tag like import TensorFlow.js in HTML page. Then we define the path of model. After that, we use load layer model and pass the path of model. For example, here, the input for prediction, it is tensor, contain number, and the shape one row and one column, and the prediction using the method predict. Okay, we will take a simple example just for to show how we can do this. Please go to this link. If you put in the chat, that will be more better. I will go to the link. This is a notebook, a very simple example, which built in Python and convert it to TensorFlow.js or JavaScript. First, install the requirement, TensorFlow.js, then import the necessary library, NumPy. We want NumPy and TensorFlow. And here we define the data will be training. We want to predict if x equals something, then y, what the value of y. If x 10, the data, if x 10, then y 5. If x 4.6, then y 5.6. So if we put any value in x, so we want to predict the value of y. We built the model using Keras, sequential, then a layer dance, 1 unit, and the input, one value, just one value, x1 value. After that, compile using a mean square error and define the optimize, fit the data, x data and y, and a box 100. Now our model ready. Using we create the model using Python. We want to save the model. How can save? Model save. Just model save and put the name. After that, we create a folder. Here, the important part, how convert. As I mentioned before, we use TensorFlow converter, input, format, class. This is the model, the name of model, and this is the folder which we created. Okay. Now the model will contain something like this. Okay. Like this. Okay. So we zip the folder and download it. Let us run all. After download the model, we put unzip the folder, then we put the model to our website or web page folder. Okay. That's all. Next, we want to create. Okay. Okay. Now our model ready for use. We want to create web page and load the converted model. How? Okay. We will create a very simple page, contain the load, this script for load TensorFlow.js. Then the script, you can write the script here, or if it's too long, just embed it. Link to the JavaScript link. So we will define a synchronous run function, the path of our model, then load layer model. We can use log to show the layers model summary, like Keras exactly. The input for the predict, we will input one value, x, when x equal 10, so y will equal what? We pass the input to model predict, alert the result. The result will be tensor. So we use data sync to get the data from the tensor, and put 0 the first result. So we can also use JavaScript to get by element. Here the tag, which called result. We print the value, the predict value is. Let us show how it's work. So this is the lart. This is y predict y hat. If you click, the predict is this value. If we click and go to the console, this is the summary. the summary of layers. Okay, we here log summary. So if you open the console, we find the summary of layers. I wish it is very clear before we go to the last example. So last example, which deal with real data, predict home price. So this is the repository. Go please to this repository. The full code here, also the slide. You can review the slide. This is the first example, the second example, and we want the predict. This is the folders, contain all code. Let us go to this example. This is real example, use real data set. So we will go through the code, which all code with using Python. And the last thing, just convert the saved model to JavaScript. Okay, the data about the price of house, and here more data or information about the data. Okay, let us run over. Okay. Import the library. We'll use NumPy, Pandas, Seaborn, Matplotlib, TensorFlow, and Keras, which embedded now on TensorFlow. This is the file of data. Okay. The dataset, I upload the dataset in my GitHub, and this is the file of data. Using read CSV, here the data contain ID, data, price, bedroom, bathroom, and so on. So we look on the data here. This is the info, the method to summarize the info about data set. We have index 20, 21 entry or rows, and the column 21 column. The model download there. Okay, after finish the run. So this is the information about data. Check if any misvalue using is null.sum. No misvalue, so it's okay. Oh, okay. No, check if there is any misvalue. No misvalue. Everything good. Now we choose the features and labels. Just I choose 4 features: bedroom, bathroom, and the square feet living, and the grade. The label will be price. So depend on these features, we want to predict the price. So we have now the labels and features. We built our data using scikit-learn, then use train and split, pass the features and labels. So now we have training test X and Y, and X testing test X and Y. We defined our model. This is the method or the function for build model, we use sequential keras. This is the layers which contain input. The input of four column and one price. Okay. After that, we define this is the hidden layer, and this is the output layer. The output layer will be the price 1. So we put 1. Define the optimizer, then combine the model, and this is the function return the model. We create an instance of model. Now we fit the model, training the model. Okay, we will pass the X data and Y data, and it is 100. So after finish the training, so our model ready for prediction. Here the prediction, use just show one prediction here. Then we evaluate the lost, here the lost, here the mean square error, and here we show one price, actually the price, the predict price, and here the actual price. Visualize all the data that here. It's not so far so good, but the idea to convert our model, save our model, and convert it. So now suppose the accuracy is very good, so we want to deploy our model. First step, save our model. Okay. Second step, install requirement, which TensorFlow.js. Second step, use or create first a model to put the model and the file of share weights, binary files. After that, we use this command, first argument, it is the keras, the format keras, then the name of model or the path of our model, third argument, which the output where save the converted model. Now, if you click, this is our model. From this step, this is our model, shared group, contain all the weights, and this is the method, the topology or the model JSON. Zip the folder here, then download it as you see here. Okay, now we finish this example. Next step, what is the next step? We want to create just the HTML and put just create index HTML, the folder of converted here, and everything is ready. This is the Jupyter or notebook. Okay, that's all. Let us read, just read before finish. Read the code. Okay, you can use separated JSON file what we do. This is for loading JavaScript, and this is the script which deal with model. First thing, we define a var called model. This function, once we upload the page, load this initial function, and the listener, add listener if we click the button. Okay, let us, this is the demo, JavaScript and demo. Okay. Once we open the page or load the page, the model loaded. Okay. Once the model will be loaded, open the page, the model will be loaded. Then we add listener. When click in this button, there are listener. So let us read the rest of code. This is the initial function. What doing? It is load the model. Here the loaded model, and here the tag called status. After finish the load model, the status B model is loaded. Model is loaded. Okay, just this for write in the console. Okay. Okay, starting loading model, finish it loading model. Okay, where our code? Yes. And this function for prediction. We define input. This is the form. This is the tag of status. And here the input. Input 1, which type number, enter the number of bedroom for input, and a button, submit. Let us go up. So input 1, get element by ID and take the value of input 1. Okay, and parse in the float. Input 2, same thing. Input 3 and input 4, same thing. Here we define tensor 2D, pass all input, and this is the shape of input. Now input ready for prediction. We use model predict and pass the model. And last thing, we show the result of prediction and use data sync and just fix two number after the point. That's all. Okay. Let us try. Number of bedroom 2. Number of bathroom. Okay, 2. Total of house square footage. Let's say 100, and the grade 4 or 5. Predict. Yeah. The predicted price is here. Okay, and here what I write in the console. Okay, where, yeah, console, what I write in the console. I wish everything is clear. Okay.
Good.
And that's it. Thank you. And if you have any question, I will be very happy to contact with me on Twitter account.
Okay, Rukia, thank you again.